Pick reactive power and voltage control. So we have covered okay, in PSOC we have two parts. The first one is operation. So we cover ED and we have discussed about all the techniques and then all your assignment as well as your project related to ED. And then we go for the control. So we have discussed about the real power control that reflects also with the frequency. Now this is the final topic is we want to control the reactive power which also reflect with the voltage. Okay, so when we say about the reactive power control, it also can be said that we control the voltage. Okay, the voltage control. So we have completed all the assignment 2, project, quiz until quiz 3. So I think by next week lah kita go for quiz 4. Tengok schedule jap. Okay, quiz 4 supposed to be tomorrow. Next week ada test kan? Next week test kat sini, test kat sini. Waktu kelas lah test. Khamis kot. Okay, so quiz maybe next week and then also test, quiz and test next week. So we try to finish by, I think by almost 3 weeks. Never mind. And then we try to look at example for the previous semester punya test. So basically power utilities required to regenerate both real and reactive power. So we P and Q, but normally we only concentrate on P because the P is the real power. Reactive power is the imaginary part, so that's why you have J. Okay. While active power is the energy supplied to run a motor, heat a home, or eliminate the electric light bulb, the reactive power is used to provide the voltage level necessary for active power to do the useful works. Okay, the reactive power is required to excite various types of electrical equipment and to energize the transmission system. So it also required to compensate the transmission system, depend on the load or its power factor. So when you have a very heavy loading, so sometimes you need to have the injection of the reactive power in order to stabilize the voltage or to maintain the voltage level at the various state. Okay, and then if you remember that you have learned in the power factor correction, so you inject the reactive power to fix the power factor, right? So when you can inject the reactive power, but need to be careful because if you inject too much, so the power factor instead of become unity power factor, it will become leading power factor. So we want to avoid the leading power factor. Okay, so we want to always the preferable is your power factor is unity power factor, unity power factor, which is your power factor equals to 1. Okay. And then to supply quality service to customer reliably and economically, voltage over control is crucial. So basically we want to look at how we want to control the voltage or how we want to control the reactive power. Okay. To maintain the nominal voltage receiving end to the system, there's a need to avoid over voltage. So kita nak maintain kita punya voltage dekat receiving end. So kalau you belajar, you ingat you belajar dekat EPS, you have a transmission line parameter, right? So you have Sending end normally will be higher, slightly higher compared to the receiving end due to the loss. But we want to maintain the voltage at the end, the receiving end. But we need to avoid the over voltage, meaning that your reactive absorption is more than your reactive requirement. And the low voltage, where your reactive generation is less reactive requirement, meaning that kalau you ingat when we say about the power system, in the interconnected power system, you have generator. Let's say we have 4-bar system. So one of the generator must become a slack bus, kan? Maknanya dia akan jadi macam tak sanggup lah. So when in the system we have a heavy loading, so instead of the propose ataupun dia supply the real power, but also it makes sure that in the system the reactive power is not when kalau tak cukup dia akan supply, kalau terlebih dia akan absorb. That's why sometimes when we have the reactive power, the slack bus, normally the power sometimes become negative. Negative meaning that all the reactive elements dia absorb. Okay, maknanya dia absorb the reactive elements. So that's why dia ada slack bus. Okay, kalau kurang dia tambah lah. Sebab yang lain semua PV control kan, PV bus. So load is changes within the requirement. So slack bus ni penting, sama ada dia boleh supply ataupun dia absorb the reactive elements. And injecting reactive power into the system raises voltage and absorbing reactive power lower voltage. Okay. So effects of the low voltage, this is the effect when you have the low voltage. The low voltage is associated with the heavy reactive loading on generators. It causes a poor performance of induction motor. It's also responsible for higher stator and rotor current. So this one reflects as well as the performance of the load. But when we have the over voltage may occur due to any of the following reasons. Sometimes we have a disconnection of loads. Biasa kalau load tu heavy sangat, cara dia ialah dia disconnect lah. So that's why kalau you tak belajar ni, tapi kalau you when you have the opportunity, kalau kerja dekat TMB, especially in the heavy country district ataupun negeri yang memang banyak industri, so you akan belajar load curtailment. Ni antara tugas engineer dekat TMB ya. Load curtailment ni maknanya which area yang you kena isolate supaya ataupun give, because sometimes your generation is cannot fulfill the demands kalau heavy sangat loading. So bila disconnection of load, sometimes when it happen immediately, so you punya voltage kadang-kadang boleh jadi over voltage. Okay, you bayang macam yang tadi kan, bila terlalu stress, bila dia putus dia akan campak luar belakang lah. So maknanya boleh jadi macam tu lah. All line switching operation or lightning strike before before your circuit breaker operated, sometimes you become the over voltage. And we have frantic effects. So normally with the long transmission line, when open circuit or lightly loaded, the voltage rise occur at the receiving end. So maknanya dia akan jadi tinggi. Okay, so this is the effects of the over voltage. Number one is breakdown of insulation, and number two, saturation of transformer may lead to production of high harmonic current. So harmonics ni ialah yang kita cuba elak lah, but it cannot be avoided. This one I think you have known. We have a class of voltage, we have extra high voltage, and then we have transmission voltage, sub-transmission, distribution. So this is the standard. Normally for extra voltage we have more than 400 kV, so this in terms of kilovolts. Okay, the highest normally plus minus 10% lah. So this is the higher permissible voltage, this is the lowest, and then this is the standard one. We have 220, 245 to 200, and then this one in terms of transmission, and this one is sub-transmission as well as this distribution 11 kV. Okay. Okay. So we have our generation, and then normally we have a tap changing transformer. Tap changing transformer also is the one type of how we want to control the voltage. Because kita boleh make, kita boleh step up atau step down your punya voltage lah. So normally when the generation produce the power, the voltage is quite low, 11 kV, so sometimes 32 kV, and then we step up to the high voltage. So this is for your in terms of, we have a bus bar, and then we have all the components. So let's say this one is receiving substation, and then we step up again. So this one is, or step down, this is the distribution, and all the things, this is the loads, and we have distribution substation. So this is the components of your in the power system. Okay, and we go for generation and absorption of reactive power. Normally it's generated by generators. Okay, because generator can be made to generate or absorb, as I said previously. Akan ada satu bus sebagai slack bus, so dia boleh absorb. Kalau dalam sistem the reactive power is very high, so dia akan absorb. Okay, and then transmission line on light loads. So you have synchronous condensers, and then we have cables. This one is reactive power generated by, and this one is reactive power is absorbed. Normally it's absorbed by loads as well as your I square X in terms of the transmission line when fully loaded, and as well as transformer. So let's take a look at the relations between voltage and reactive power. Okay, so let's say we have a sending end as well as a receiving end. So this one is bus 1, bus 2. So the power transfer from bus 1 to bus 2. So we have two voltage. We have V1 as well as V2. So the power transfer is P plus JQ. And also we have Z in terms of your impedance that consists of R plus JXL. Okay, and initially we have voltage. This is the magnitude as well as your angle. So we can use what? We can use Ohm's law as well as your Kirchhoff current law. So when the power transfer, or this is plus minus, right? Bus can be represented as a node. Ingat, so you have plus minus, ground, plus minus. So this one is V1, this one is plus minus, this is V2, and then the current flow here, this is the current flow. So when the current flow to the transmission line, we have this one, you have real and reactive elements. So plus minus, you have a voltage drop. Yeah, and okay, when you do this KCL or KVL, so V1 minus ni VD, VD minus V2 equal to 0. And then V2 you bring to here, so you get V2 equals to V1 minus VD, where your VD is what? V1 equals to IZ. Okay, so you get this equation. And also we know that our power, your S equals to VI conjugate. Okay, so and then we know that our power V P plus JQ. So I ni you bring as a title. So bring all the thing here. So you can dapat P minus JQ divided by V1 conjugate. Dia mula plus kan. And then bila you conjugate akan dapat negative. And then normally V1 ni as a reference, kalau kosong, kalau conjugate pun dia akan maintain kat kosong. So that's why you dapat your V1 as a reference phasor. From this equation, you masuk balik ke dalam equation 1. So you dapat this equation. V1 minus this one is I dot Z. And when we assume, normally when we learn about the transmission line, we assume that your X is much greater compared to your R. So that's why normally R kita assume kosong lah. So yang tinggal ialah V1 minus JP divided by 1 VL. Jadi you kembangkan lah. Minus Q over VXL. So you get this equation. Okay. And this is the when we learn about the transmission line, we must know also the phasor diagram. Okay, this is the phasor diagram that represented by this equation. Okay, so V1 is your reference. Normally dia dekat salah lah. So and then your minus J, right? So minus dekat bawah ni. So that's why your V2 here, we have your angle. And then this is your Q, P. So here, minus P over 1XL minus Q over 1XL. So that's why dapat ini ya. Minus P sebab di bawah, minus Q sebab di ke sana, ke kiri. Okay, so this is the representation. So in other words, it's clearly that we can clearly observe that load at V2 is not much affected due to the real components. Okay. Of the load P as the normal to the normal vector V1. And then we assume the drop due Q of load is directly subtracted from the voltage V1. And then normally we can assume that this one is not much affected. So that's why we can simplify. The equation becomes V1 minus Q divided by V1 XL. Assume voltage drop due to P is equal to 0. So the equation 4.3 becomes this equation. Okay, to keep the receiving end at voltage P2 fixed at a particular sending end voltage V1, the drop Q must remain constant. So your Q divided by V XL, Q can be adjusted to keep these quantities fixed, right? By normally we can use by connecting the shunt capacitor or synchronous capacitor. Or QXL can be kept constant by introducing the capacitor which reduces the net reactance. And voltage variation will be more larger for larger loads. Could be controlled by switching the suitable series capacitor. So this one how we control the voltage. So you can see here that we can control the voltage or we can control the reactive power by implementing Q. We keep adjusters to keep this quantity fixed, or we just QXL to make it kept constant. Okay, by this implementing these two. So that's why we can say when we want to control the capacitor, we control the reactive power. So we can control by implementing the reactive elements. So this one, the capacitor, normally we refer to the reactive elements. Whether you want to put in shunt capacitor or synchronous capacitor. Okay, that is the proof that how we want to control the voltage normally, or we want to control the reactive power, so it reflects. Or to control the Q, we adjust the V, or we control the V, we adjust the Q. So this is the proof. Because when we talk about the real power, it reflects directly to the frequency. But when we talk about the reactive power, it reflects directly to the voltage. So sometimes I call it not reactive power, so sometimes we call it voltage control. Okay. Okay, now let's take a look at the power transfer and reactive power. So when we just now we analyze in terms of voltage, right? So now we want to analyze in terms of power transfer. So let's say we have our power transfer SA, represent for the apparent power from bus ataupun your sending end. SB is the receiving. V is our receiving end voltage. E is excitation of the power of the voltage for the A. So kat sini kita boleh derive, and then we have your Z. Now all our components we kita tulis dalam bentuk macam ni lah. Magnitude, angle, your Z also magnitude and angle. So we know again your SA, okay, SA equals to VI conjugate. Now our V is E lah. Okay, EI conjugate. So as we know that our I conjugate, I equals to E minus V divided by Z, kan? Okay, E minus V divided by Z. You conjugate kan dia, dan you bentuk, make it in terms of vector E, and then we have the magnitude there is theta, and your V normally, because we want to maintain the voltage level dekat receiving end, kan? So that's why kita maintain dia sebagai reference kosong lah. So E theta minus V theta divided by Z, where your Z also you have theta, ada angle, conjugate kan. So this is the real components. Normally kita boleh buat dia keluar. Tak? So you dapat E divided by Z. So this is your phasor. Phasor normally kalau kita bahagi dia akan dapat tolak kan. Ni kena betul So theta tolak theta dia bahagi satu-satu kan. Ni sebenarnya dia ialah E per Z sebab dia boleh pecah dua kan. V bagi dengan Z. So E ada angle theta. Ni ialah theta. Ni kosong. Ni theta. So Z ni ataupun dia boleh kembangkan lagi dulu. Sebelum dapat macam ni, dia dapat E over Z. Angle dia ialah theta minus theta. Betul tak? So yang ni V per Z. Kosong tolak theta dia ialah minus theta. Okay. Kan? Kemudian dia conjugate kan. Kita nak hilangkan conjugate, dia terbalik lah. So that's why dapat E over Z. Theta tolak theta minus V over Z. Ni ialah theta sebab dia kita conjugate kan. So that's why dapat yang ni. Z ni kita faktorkan, letak kat luar. So dapat E theta minus theta minus V theta. Conjugate tadi kan. So nak hilangkan conjugate, kita jadi positif. So that's why dapat ni. Okay, and then you can rearrange. Ni darab kan. Bila you darab, theta ni dalam ni bila darab jadi tambah kan. So tambah-tambahkan jadi cancel. So dapat theta. Yang ni bila darab akan tambah lah. And then you kembangkan lah. E square equals E square over Z. For this one E darab E dapat E square. And then E V divided by Z. Then you apply Euler. Remember Euler concept. Dalam ni kan, you akan dapat cos theta plus J sin theta. This one cos theta plus J sin theta. And then yang ni you pakai, you kena pakai, ingat belajar dulu dekat AdMath. Cos A plus B tu kena dapat apa? Cos A cos B sin A sin B yang tu lah. Okay, so dalam exam, you kena apply yang ni lah. Ni dia simplified depan. So you kena tunjuk jalan kira macam mana you dapat. Okay. Ini dia susun balik ni. Dia susun balik. You dapat the real element yang cos ia ialah P. Dia ialah real element. Yang sin dia ialah reactive elements. Okay. Kena tunjuk lah. Cos A cos B sin A sin B. Saya pun tak ingat. Okay. Kalau sin A cos B sin. Benda tu. Okay, similarly for SB, ni SA Okay. Then for SB sama, cuma dia sekarang ni ni PA, PB. And then let's say our R is kosong, biasalah. We assume that our X is much greater than your R. So you dapat Z equals to JX. Ataupun when you change to this one, you X, the angle is 90 degrees. So kat sini you boleh simplify the equation like this. So PA equals to EV over X sin theta, QA E square over X minus EV over X cos theta, PB EV over X sin theta, QB EV X over X cos theta minus V square over. Beza sikit lah, terbalik. So that is the equation. Okay, until now ada soalan? Kelas ada soalan tak?
Tak ada, sir.
Tak ada, boleh tengok contoh lah. Okay, tengok. Let's take a look at example. So interconnector transfer 60 megawatts between two 132 kV, three-phase power system having the same frequency. Assume that the interconnector is 100 km long and that each line conductor has a reactance of 1 ohms per kilometer and negligible resistance. Determine the kVA supplied by the interconnector. Okay. So transfer 60 megawatts, meaning that you must receive 60 megawatts lah. Maknanya dekat receiving end ialah 60 megawatts. And your E ataupun your V is 132 kV. Our Z ataupun X ialah 1 ohms per kilometer. So line 100 km, you kena darab 100 km. Ni antara biasa kena buat lah. So you dapat your X ialah J100 ohm ataupun 100 magnitude 90 degree. Okay. And then kita guna yang mana? Kita guna PB, equation PB. Sebab you nak cari theta sending end tu berapa. Okay, determine the kVA supply the interconnector. You nak cari your ni lah. Okay, so PB kita tahu 60 megawatts. Your EV, since E dengan V sama 132 darab 132 divide by your X 100 cos 90 degree minus theta ni nak cari. Tolak 132 square divided by 100 cos 90 because cos 90 is 0. So you can rearrange this equation to find your theta. So you dapat theta 20. Dia cuba. Once you dapat theta 20, you boleh cari Q. So Q ialah EV over X cos theta minus V square over X. So you dapat Q 10.5 MVAR. So this is your SB. PB plus JQ 60 tolak 10.5 MVAR, you dapat 60.9. Okay. Itu depan. Okay. Kita tengok besok lah. Okay, saya rasa itu saja untuk hari ini. Ada soalan kelas?
Sam.
Yep.
Yang tadi tu kita guna PB kan equation dia. Kalau guna PA pun boleh kan?
Tak, sebab soalan dekat. Soalan ni tengok soalan lah. Ni yang soalan ni. Bila dia kata sistem tu ialah 60 megawatts, dia sebenarnya refer to receiving end. Faham tak? So when they say transfer 60 megawatt, maknanya kita nak sampaikan dekat receiving end tu 60 megawatt, bukan sending end. So that's why kita kalau sama juga kalau you belajar dekat EPS dulu kan. Ingat belajar kat EPS dulu, transmission line parameter or transmission line model. Kalau dia kata system is 132 kV, normally dia ialah dekat receiving end tu kita skipper. That's why you pakai PB. Okay.
Yes, sir.
Kita akan tengok the relation between the sending end yang ni ya. Ni antara yang penting kak. Ni biasa masuk exam. Macam mana kita tengok your the power transfer to a series impedance. Ni simple, sama je semuanya. Cuma ni cara kita tengok impact of your Q dengan V tadi lah. Okay. Itu antara yang masuk exam di sini. And then we go for the operation of generator on infinite bus. Then we go for the methods control. Okay, and then kita akan tengok contoh-contoh soalan saya lepas. Okay, ada soalan lain? Okay, kalau tak ada kita stop kat sini. Jangan lupa buat you punya projek. Saya tengok ada seorang je yang baru submit dekat kalam dan juga yang penting sekali submit dekat turn ini lah. Make sure you punya turn ini hijau lah. Okay. So kita akan emphasize pada contoh-contoh soalan-soalan saya lepas lah. Okay. In order to you to, because I think it's not so much saya expect sebenarnya ada kelas face to face, tapi oleh kerana COVID ni dia tak ada kelas face to face. So basically saya akan emphasize pada apa ni, kemudian kita akan tengok sampai, kalau tengok saya punya modul pun tinggal kat office. Modul kita sampai tak sampai booster transformer ni lah. Notal memang sampai bawah ni, tapi di luar ni saya sebab you belajar facts dekat subjek lain kan. So basically untuk kelas saya ni bila reactive power control ataupun voltage control kita akan sampai sini je biasanya. Step changing transformer saja. Okay, sampai sini. Okay, and then kita cuba buat contoh-contoh soalan-soalan yang lepas. Okay, ada soalan lain? Kalau tak ada, kita stop. See you tomorrow. And then tomorrow juga kita akan cuba tengok contoh quiz. Kita ada satu quiz lagi dan satu test. So quiz kita akan buat 19, test 20 lah. Quiz 26, test 27. Okay. And then 2 minggu ni kita boleh buat revision lah. Okay. I think that's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you.
Thank you, sir.